Okay, so the next type of reaction that we're going to be looking at is single replacement reactions. But in order to be able to do single replacement reactions, you have to understand something called the activity series. Now, attached to your files, I've attached a picture that a chart that looks like this. Okay. Now, your activity series, the more active metals are at the top. So lithium is the most active metal, and gold would be the least active metal. So the higher it is on the chart, the higher the activity is, okay? So we have to understand this. So looking at your example problems and your activity series, calcium or hydrogen. So calcium is higher than hydrogen. So we're gonna circle calcium as being the more active metal. Aluminum or lithium. Well, lithium is higher up on the list. So it's gonna be the more active metal. And sodium or lead. Okay, so sodium is towards the top, lead is towards the bottom, so sodium is going to be the more active metal there. Okay, so we have to understand that because whenever we're doing single replacement reactions, the more active metal is going to displace the lesser active metal. Okay, so for a single replacement reaction, it has the general form A plus Bx. And what's pretty much going to happen in all these cases is the positive ions, the metals are going to flip-flop. If it's more active, so if A is more active than B, they're going to switch out. Okay? Now, there are cases which we'll look at where we're going to deal with nonmetals. And we'll talk about that in a second. If A is not more active than B, then there's no reaction. Okay? So, for this case, iron and copper. And it says use copper 2 and use iron 2. So what we're going to do is we're going to write our reactants. Okay, and I'm going to look at these two. Okay, iron. Iron is higher up than copper, so they're going to replace one another. Okay, and so we're going to flip-flop those two ions. So iron is going to have a +2 charge in this case, and sulfate is SO4. It's going to have a -2 charge. There's no need to crisscross because they're equal and opposites. And it's going to kick out the copper. Now, we got to make sure we balance it. And everything should be balanced because you got one copper, one Fe, one Fe, one SO4, one SO4. It's balanced. Okay, silver nitrate. So silver is Ag with a +1 charge. Nitrate is NO3 with a -1 charge. And I'm reacting it with nickel. Now, what we can do is if you feel more comfortable writing it like this, or we could write it like this to tell if we're going to flip them out. Okay? So, nickel is higher up than silver, okay? So nickel is higher up than silver, so they're going to exchange out. So we get nickel, and I said use nickel 2. Nitrate is NO3 with a -1 charge, like that. Plus, and we're gonna kick out the silver. Now we gotta balance this. So I have 2 nitrates on this side, I need to put 2 nitrates on this side. 2 Ags, 2 Ags, 1 nickel, 1 nickel. It's balanced. Okay, and that's how we're going to use our activity series to see if things kick out. So if you feel more comfortable writing the single element first and then the compound second, I'm okay with that. Okay. Okay. Now, replacement of hydrogen and water by an active metal. So previously, what we did is we wrote water is HOH. Okay? So, we're going to look at it that way. So, is sodium more active than hydrogen? Okay, so we're going to look at these two. Sodium is higher up than hydrogen, so they're going to flip out. Okay? So, we get Na has a +1 charge, OH has a -1 charge. And then we're going to kick out a hydrogen. Now, when we kick out hydrogen, hydrogen's diatomic, so it can't be by itself. Now, we gotta balance it. 2 hydrogens on this side, I need to put 2 hydrogens on this side. 2 OHs, 2 OHs. 2 sodiums, 2 sodiums. It should be balanced. Okay, and we're gonna do the same thing with the next example. Magnesium plus water. Mg plus water, we're gonna write as HOH. Now, magnesium is higher up on the activity series than hydrogen, so they're gonna flip-flop out. Mg has a +2 charge. Hydroxide is a -1, so we're gonna crisscross like that. And we're gonna kick out the hydrogen. Okay, remember hydrogen is diatomic, so we have to make sure that we write H2. Okay, so let's balance this. I have 2 OHs on this side. I need 2 OHs on this side. 2 H's, 2 H's, 1 Mg, 1 Mg. It should be balanced. Okay? Now, let's talk about the next type of example. It's pretty much the same exact thing as the previous ones. Okay? So we're going to look at zinc and hydrogen. Zinc is more active than hydrogen. It's higher up on the activity series, so they're going to flip-flop out. So zinc has a +2 charge. Chlorine has a -1 charge. We're going to crisscross, so we get ZnCl2. Plus, we're going to kick out the hydrogen. Okay, so we're going to go balance. You got 2 Cl's here and 2 H's right here, so I'm just going to double this right here. And it should be balanced like that. If you wanted to rewrite it down here, I did a bad job of doing it on this one. That's what it should look like. Okay. Next example, magnesium is Mg. Nitric acid. Okay, so all acids start with H, so nitric acid's HNO3. This has a +1 charge, this has a -1 charge. If you don't remember your acid rules, you need to refer back to your notes. Okay, now Mg is more active than hydrogen, so they're going to flip-flop out. So you get Mg has a +2 charge, NO3 nitrate has a -1 charge, and we're going to crisscross like that. And we're going to kick out the hydrogen. Now, evolution of hydrogen gas means that it's going to be popping or it's going to be fizzing. Okay? So all of these examples, you're going to have some sort of popping or fizzing whenever you mix the 2 chemicals together. Okay? Now we're going to balance. We've got 2 nitrates on this side. I need to put 2 nitrates on this side. 2 H's, 2 H's. 1 Mg, 1 Mg. And it's balanced. Okay. Now, occasionally you're going to have to deal with the activity series of nonmetals, okay? So nonmetals increase as you go up a group. Let's see if I got my periodic table. It's there somewhere. Let me get my periodic table really quick. Okay, so if we're talking about nonmetals, they're going to increase as you go up this way. Most of the time, you're just going to be dealing with the halogens. Okay, so I'm going to rewrite it like this. Cl2 plus NaBr. Now, if Cl is higher than Br, which we can see from our periodic table, Cl is higher than Br, it's going to kick it out. It's going to flip-flop the nonmetals, the halogens. So these two are going to kick each other out. Sodium has a +1 charge. Cl has a -1 charge. We're going to kick out the bromine, which is Br2. Now, we got to make sure this thing's going to be balanced. So we got 2 Brs on this side. I need to put 2 Brs on this side, 2 NAs, 2 NAs, 2 Cls, 2 Cls. It's balanced. And the last example we're going to do in this section is chlorine plus aluminum bromine. So I'm going to go ahead and rewrite and flip-flop them. Aluminum has a +3 charge. Bromide is Br with a -1 charge. So it looks like that. Now, is chlorine higher up the group than bromine. It's higher. So they're gonna exchange with one another like that. Okay, so we get Al with a +3 charge, Cl with a -1 charge, we crisscross. And we're gonna have Br2 on the outside. Now, it's Br2 because bromine is one of those diatomic molecules that we have to consider. So balancing wise, okay, so the least common multiple between 2 and 3 is 6. So I need to double this, and I need to put a 3 in front right here, okay? And then I have 6 chlorines, so 6 chlorines. That's how we balance it. Okay, so this was your single replacement notes. I will have a video that goes with the practice problems.